So just a brief overview. Ben gave a little bit of introduction. So I am currently a postdoc on the Erasmus campus. I completed my PhD there a few years ago. About 2 years ago now, in marine physics. And my background is also in atmospheric science. I first got involved with actually Frost a few years ago. There's a program, Frost Science, there's a program called the Impact Program at Erasmus, where we host high school students during the summer. We're kind of like lab coaches for them for a few weeks. And one of the projects that we worked on was related to machine learning for earth science. My background is done some work for NASA and NOAA as well in the past. So I am affiliated with CSTARS, the Center for Southeastern Tropical Remote Sensing. This is a satellite campus to UM. That's near the Zoo, Miami, and South Miami. And we are satellite acquisition, ground receiving station. And we do a lot of active and passive remote sensing processing for land, ocean, and atmospheric applications, storm forecasting, damage assessments, these type of things. So I'll talk about some of the work that we do in regards to satellite remote sensing. So just a background on this project and how it came about. So we're specifically looking at atmospheric gravity waves. These are small-scale oscillating waves that appear usually as bright to dark areas within the satellite image. They're generated from mountains, not just from tropical cyclones or hurricanes, fronts and convection. Specifically, my expertise is with synthetic aperture radar, which is high-resolution satellite imagery that resolves the ocean, atmosphere, and land applications. I think Sam gave a little bit of intro on it in his talk on remote sensing, and this is at meter scale resolution. So we have sensors that can actually image the Earth at 50 centimeters resolution, which is extremely high from space. This is an example of a C-band Sentinel-1 image that's 10-meter resolution. And this research was really got me interested in looking into these satellite image atmospheric gravity waves from, I don't know if Dave Nolan's still here, but his paper that he published analyzing some of these features within buoy data. So I was really interested in pursuing this with the IDSC grant because there's a lack of research on these types of features in the SAR imagery. This project is really useful for exploring the relationship between these atmospheric gravity waves and tropical cyclones. And there's currently no labeled data set available for satellite imagery of these features. So that's something that I wanted to develop. So I have been working for a long time with my intern, Ryan. He's an undergraduate at UM, marine science and meteorology major. And this definitely took a lot longer than we anticipated. Creating this labeled training data set so that we can train our deep learning algorithms on. So we looked at National Hurricane Center named hurricanes from 2019 to present, so the past 5 years. And we found presence of about 20% of storms contain these atmospheric gravity waves. And we looked at a lot of different imagery, SAR imagery, and also as our research developed through our testing of the deep learning models on another SAR data set, we decided to include GOES visible satellite imagery into our labeled data set. So we've been working on that. There's a lot that goes into this. not just looking at pretty satellite imagery, but a lot of image processing involved, especially with the SAR, that we need to do in order to create this data set. But to start out, another piece of this project is really also on the labeled data set of different features that we have for SAR imagery. There hasn't been deep learning training. This is an example of a data set that can be used for applications in deep learning, machine learning. This is a paper that was published with 37,000 SAR imagery of 10 geophysical phenomenon. So these not only do atmospheric gravity waves influence tropical cyclone development and intensity, but also these other types of features present within extreme storms, like wind streaks, convection cells, rain cells, et cetera. So the first step to this analysis would be to train using these other features. And there's, you see up here that there's no indication of the atmospheric gravity waves category, and that's most likely to do with the fact that for the SAR, they can be easily misinterpreted with oceanic features like ocean and tidal waves. They appear as very similar, so you have to have a trained expert that can distinguish between the two, and there's not that many out there that are experts with dealing with this type of data. So we applied a couple different algorithms to this data set in order to see if we were properly identifying. So using a deep learning model approach with Inception version 2, we weren't doing very well. So our AUC, area under the curve, was about 0.6, so not really distinguishing between our different features. But when we apply a transfer learning model towards the bottom, was a fine-tuned model using optical imagery, we get much better results with an AUC of 0.95. And so our future work, we're still finalizing this labeled training data set with my intern, and then we will train using these algorithms because likely the transfer learning model to this data set to see if we can properly identify these features. And then we can evaluate the relationship between these features without having a trained expert, and relate the atmospheric gravity waves to storm intensity, and even some of these other features in the present in the image, like wind streaks or convection cells. And I think that's all I have. Yeah.
Quick question for Samantha. Go ahead, Mo.
Do you think you would benefit from the algorithm that David Chapman was talking about?
Yeah.
Not needing a lot of labels?
I think so. I think you still would need an expert to just make sure that we're identifying the proper features, I think, but that would definitely aid, and because we're a little bit sparse on the training data. So I think that would be great, yeah.
Okay. Thank you, Samantha.
Yeah.